Now part B is the velocity. We had seen kind of when we were studying the differentiation with the rate of change. Normally in physics, if you remember, the average velocity is found by change in speed, change in time. So between two different time intervals, the average one. But by using, okay, if you have the graph, for example, if you have 2 points, you can find the average velocity. But with the differentiation, we had learned new concept. It's the instantaneous velocity, means that the velocity at the exact time, at the particular time. So we find by using differentiating the displacement. So what the sign of the velocity will tell you, when the velocity is positive, it means you are moving to the right. When the velocity is negative, it means you are moving to the left. When it's zero, you are at rest. So the main difference between the velocity and the speed was, in the velocity you have direction to the right or to the left. So let's see in problem, you have in your book some solved question, check it also. Now we have the displacement graph, describe the initial position of the object. It means that, okay, the equation is not given, everything is given on the graph. So in part A, what do they ask? What's at time 0 your location is? You are at -2. From picture, from the graph, we can see it. Part B, at what time is the object at the origin? So if we go from here, origin is here. At what time it crosses this bar? And we can see at time equals to 6 seconds. In which direction is the object moving when t is 5 seconds? As you can see, it's on the negative side and it's moving towards the positivity. The displacement means you are moving to the right. And at what time does the object change direction? From the graph, if it's displacement 1, it's not the root, but from here, you are going down from when you change the direction. At this point, I guess it's 3 seconds, and also here, when you change the curve. When we know when change the direction with the velocity, but here I cannot see the velocity, so you have to go with the gradient. We know that this point gradient is 0 when you change your direction at 3 seconds, and also at t9 seconds you change your direction. Now draw the sign diagram for the displacement and the velocity. So for displacement, the sign diagram will be, you are at the at time 6 you change from negativity to positivity. It's a displacement E, and for the velocity we change the direction at 3 and 9. So the main rows 3 and 9, and we know here from the gradient the velocity is positive here, and here are negative gradients. Here are negative. And last part, find the instantaneous velocity of the object. If you were given the function, for example something like this, you will take the derivative and find the instantaneous velocity. But here we have the graph at time 7. 7 is here. So already in the picture they give you the line. So you have to just calculate the gradient of this line. The gradient of this line will give you instantaneous velocity. So to find the gradient, we need 2 points. Let's pick 2 points. Let it be the first one, and let it be the second one. So what are the points? Are 5 and 0. I have points 5 and 0, and I have point it's 9 and 4. So to find the gradient equals to 4 minus 0, 9 minus 5. So from here we can see it's 1 meter per second, the speed. Now another thing, finding displacement from the velocity. If we differentiate, it will give us the velocity. If we integrate, we'll find the displacement. And when we do integration, of course, we usually have what? Plus c. And to find this extra c, the constant, some extra information will be given. Normally, it's at the origin, your location at the origin. So also, when you find displacement, you do integration, you give displacement, but the distance traveled, the important part, is by using the absolute value. You can do it easily by using your calculator with the absolute value. When you calculate, it will give you the distance traveled. Without absolute value, it will give you the displacement, the main difference between them. Now let's see in one question, a particle has the velocity function 1 minus 2t. It moves in a straight line. Find the time when the particle reverses direction. So when it reverses direction, when, okay, this one equals to 0 and time is 1 by 2. So the sign diagram will look like this one, 1 by 2. Before this one, if I put, for example, 0.1, it will be positive. You are moving to the right, and after 1 by 2, you are moving to the left. And yes, find B. Hence, find the total distance traveled in the first second of the motion. Check your answer by evaluating. Okay, we can do this by using calculator. We know that at 1.2, it changes direction, right? So you move to the right. Let's say you are here, you are moving to the right in the first second. At t1 by 2, you change your direction, and again, you have to come to this wherever you started. Let's call it the origin. So we have to calculate this distance traveled. So what do? I just go from 0 to 1 by 2 and will multiply by 2. So it will be 1 minus 2t. And what will be t minus t squared between 0 and 1 by 2. So it will be 1 by 2 minus 1 by 4, which will give us 1 by 4. So this distance is 1 by 4. If we double it, it will be, distance is 1 by 4, it will be 1 by 2. So distance traveled is 1 by 2. How about the displacement? For displacement, we do the same, but without absolute value. You can check with the calculator this part, whether you find the correct answer. For finding displacement, we just do from 0 to 1, 1 minus 2t. It will give us displacement. And actually, we have the same integration. It will be t minus t squared between 0 and 1. So if we input it, as you can see, it's 0. As we were expecting, you are coming to the origin from where you started.